What's up, ladies and gentlemen? I'm David Myers, teacher of mathematics at UTC South Durham. We are in a strange time right now, and most of you are sat at home thinking, well, this is all well and good, but what about my math? Perhaps you're in year 11, and you know fine well that you want to do A-level mathematics next year, or a course that relates a lot of the GCSE mathematics, and you need to get that course finished off. Maybe you're a parent sitting at home thinking, I need to make sure that they're focusing on their mathematics, but I haven't looked at GCSE maths in years. I can barely remember indices, let alone trigonometry. If the answer to any of those was yes, or that describes you, then this channel is for you. I'm a maths teacher and I want to share my lessons and my explanations of GCSE mathematics with as many people as possible to make sure that we're all keeping up with the GCSE mathematics content. Before we get started, however, I want to show you the website where you can get a copy of the resources that I'll be using in these slides for yourself. They're all free, they are all A-star quality, and they will be absolutely perfect for you at home if you want a slightly more interactive series of lessons. The website we'll be using for these videos is drfrostmaths.com because it is jam-packed with free resources for absolutely anyone. Whether you're studying GCSE mathematics, maybe you're in Key Stage 2 or 3, even at A-level mathematics and those wishing to study mathematics at university, there are resources for you available on this website. If you're just wishing to practice a single skill, you can type in the name of that skill, say for instance Pythagoras theorem. There's a set of questions that you can try and get instant feedback on, as well as other videos from Dr. Frost himself. In the meantime, what I'm going to be doing is putting the slides on screen with my explanation over the top, in the same way that I would deliver a lesson to every single one of my students. What you can do at home is go through these videos at your own pace. Rewind as and when you need if you didn't quite catch an explanation. We'll go through some trial questions to help you see if you've got it, with an explanation for some of the slightly harder questions that appear. They will then be left on the screen, the main questions, so that you can go through them. Half of the questions will usually be revealed after a few seconds, and all of the questions' answers will be revealed after that, so that you can learn interactively as best as you can at home. The links for all the slides that I use will be left in the descriptions, as well as any other websites that I happen to use as part of the resources. In the meantime, let's do some maths.
Today we are looking at substitution. For those of you who know anything about football, you're in a better position than I was when I learned about this, because you know that it means when one thing goes off, the other comes on. We replace one thing with something else. The same is going on in here, looking at 3x squared when x is 2. Rather than saying 3 lots of x squared, we are saying 3 lots of 2 squared. If you think back to BODMAS, BIDMAS, order of operations, then you'll realise why this question is being asked. It's a very common error when we know that we are now looking at 3 times 2 squared, because we are replacing x with 2, then we need to do 3 times 2 squared. The problem is that loads of people would say that 3 times 2 is 6, therefore 6 squared is 36. We need to be careful and think back to BODMAS or BIDMAS, as whatever you called it, and remember that squared takes precedence. Squared is done first. AKA we are doing 2 squared, which is 4, times 3 to get 12. You might want to think about it very carefully. Before we used to say 3 times x squared. We did that in the algebraic expressions video. It will help to think of it as 3 lots of x squared. 3 lots of 2 squared. That will give you 12. I'll show you a few more examples. If we have a squared plus 2b, then what we're actually looking at here is a as 2 and b as minus 3. So this is, or was, a squared. It is now 2 squared, plus 2 lots of negative 3. A squared, 2 squared is 4. 2b, 2 times minus 3 is minus 6. And 4 plus negative 6 will give us negative 2. BC, minus 3 is b, c is minus 4. That becomes minus 3 times negative 4, which is positive 12. And positive 12, take away that negative 4, becomes 12, take away a minus 4, which becomes a 16. Just bear in mind subtracting negative terms. You might want to practice that if you haven't had a chance to recently. B squared, this is minus 3 squared. Do again be careful with that. Loads of people will tell us that that's minus 9. They are lying to you. Because when we square a negative term, it's going to become positive. Because it's minus 3 times minus 3. And a minus times a minus is still a positive. So this here becomes a positive 9. Take away a c. 2 times negative 4, that's negative 8. So we are looking at 9 take away negative 8. Add those together to get a positive 17. A few more examples for you. Right off the top of my head, 6z squared. We now have x is minus 1, y is 5, and z is minus 3. So z squared will become minus 3 squared, positive 9, and 6 times 9 will give us 54. 10x squared. X is the minus 1. Minus 1 times minus 1, positive 1, multiplied by 10 to get positive 10. Z being minus 3, we are now going to do 4 times minus 3 to give us minus 12. X plus 2z. X is the minus 1 from before. Z is minus 3, so 2 times minus 3 is minus 6. Minus 1 plus minus 6 would give us minus 7. Y squared minus z squared. If y is 5, then 5 squared will be 25. 25 take away z squared is 9, we know this from before. 25 take away 9 gives us 16. xz. X is minus 1, z is minus 3. That becomes minus 1 times minus 3 to give us a positive 3. And 5 times minus 3 gives us minus 15. That becomes 3 plus negative 15 to give us negative 12. As per always, what I'm going to give you do is chance to try this out for yourself. A timer should appear for you now. That is how long it's going to be until I reveal the answers. What we should get from this, folks, is that 5z squared is 20, 4y squared is 36, and so on. If you got all those right, then you are doing absolutely incredibly well. If you didn't get them right, just check where the mistakes are. It's always handy to see where the mistakes are in the working out. It prevents you from working them again. If you put a cross and shift on, you're never going to know what the mistake was. So please do keep checking. We can use substitution in Formulae. We can use Formulae to help us predict exactly what is going to happen and when, or how two things occur. We use Formula to convert between, say, pounds and dollars and euros. We can convert temperatures, speeds, distances, areas, you name it. There is usually a formula for it. But say, for instance, in here, somebody may have taught you that to get from degrees Celsius, that's temperature, to degrees Fahrenheit, you roughly multiply by 2 and add 30. It's actually a little bit trickier than that. Here, to get from Celsius to Fahrenheit, the actual formula is multiply the temperature in Celsius by 9 over 5 and add 32. The reason you've been taught to double it and add 30, if you have, is because 9 over 5 is pretty close to 2. It's specifically 1.8. And 32 is close to 30. The actual conversion formula, temperature in Fahrenheit, is equal to 9 over 5C plus 32. Well, how do we use that? If we know that C is, say, for instance, 10, so it's 10 degrees Celsius, we can figure that out in Fahrenheit by doing 9 over 5 times 10 plus 32. It will help you to bear in mind that 9 over 5, as I pointed out, is 1.8. Because now we can figure out very, very easily that 1.8 times 10 is 18, added to 32, and we get 50. So 10 degrees Celsius is equal to 50 degrees Fahrenheit. What about if C is 0? We can substitute the C as 0 in here again. 9 over 5 times 0 is 0, and 0 plus 32 gives us 32. And what about when C is equal to 30? We can use a little bit of a trick here. We know that when C was 10, then we were looking at 1.8 times 10, which is 18. We can multiply that by 3. Give you a few seconds to figure it out. 54. And 54 plus 32 will give us 86. That is the power of substitution, folks. You can take any temperature in degrees Celsius and convert it to Fahrenheit using this key formula. If you want a real challenge, if you kind of know about substitution and you think, yeah, all right, I'm getting the hang of this pretty easily, can you, using this formula, tell me when the temperature in Celsius is exactly the same as the temperature in Fahrenheit? That should keep you occupied for a while if you've never heard that one before. Okay, I am going to make myself just a pinch smaller here because I realise I'm covering up a fair few of the answers. What I will do is reveal the answers to you in a bit, as I have done before. I'll get a timer going on the side so that you can see roughly when the even questions are going to be answered, and then when all of them are going to be answered. Do try and pause the video so you can have a go at as much as you can for yourself. Very, very well done if you got half of those right. Fantastic work if you got the majority of them right. As always, if you've put in your absolute 100% and you've been scrolling back through the video to try and help you out, absolutely first class work. Really very well done at home. But as far as substitution goes, that's it.
That's it for today, folks. I really hope it's helped you out at home. If it has, please click on the subscribe button. Don't worry about the likes, I'm really not fussed about those. I'm not after YouTube glory or anything like that. I just want to know that you are feeling more confident in maths at home. If there are any topics that you really want me to go through, please just put it in the comments as well. The resources are also in the description below. You can click onto those and follow them through. There's Dr. Frost Maths. There's a link for the UTC South Durham where I work. If there's anything else that you need information on, please get in touch. Otherwise, take care.